we just have a presentation or no lecture, right?
Yeah, no lecture, the final presentation.
So how long for each group? How long?
20 minutes.
20 minutes
Yeah,
each.
each of us maybe 2 to 3 minutes.
2 to 3 minutes. Okay.
Oh, I see Supriya is here. Okay.
Yeah, hi.
Hello. Hi, guys. So let's get started.
Okay, let's go through one by one.
Okay, so we are group 3, and our topic is transactions fraud detection. And this is a table of contents. Blah, blah, blah. And the first part is objective statement, secret.
Yeah. So our project is about transactions fraud detection. So our main objective is to detect the suspicious incidents happening in the when we do a transaction and report them before it's going to get complicated. So generally, compared to the basic detection systems, our machine learning fraud detection approach has more benefits. Our project will focus on this machine learning approach so that we can achieve more advanced improvements on the existing transaction detection systems.
Eden.
Oh, he's in class right now.
Okay.
Okay, next part.
Okay.
Next part. It is my part, and yeah, okay. Yes, our data set from Kaggle. So IECS fraud detection links, blah blah blah. We have 4 data set, blah 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 blah. Our goal is to improve the efficiency of fraudulent transaction alert of million people around the world. Next, this is our the shape of our data set and the type of feature. You can see each the first test identity have a blah blah rows, blah blah as 40 columns, blah blah blah. Next. Okay, this is our overview of our technology, and the language we use Python. IDE is VS Code tools. Jupyter Notebook we use to create our document, and the libraries NAMI, Pandas, Matplotlib, and 8 tools, sklearn, and the model we have 5 models, and the first one XGBoost Lite GPT decision tree, random tree, cat boosted. Next. Okay, done.
The next part is data exploration, and yeah, next. The first one is well, exploration some key feature. The first one is fraud. We can see in the plot that it's really unbalanced in its fraud features. It's about 67 to 3. Next part, next. And the next feature is transaction amount. It's the transaction amount in each transaction, and we can see in the plot that we have got the basic statistics and the quartiles, and we can find that if the fraud is more frequent to occur if the transaction amount is high. The next. And the transaction amount skewness, it's as we expect, and we can see in the heat map that the transaction amount is has highest correlation with V12. Okay, the next. And we also do the chi-square test, and the following table has shown the product CD and card 4, card 5, and card 6 degrees of freedom and degrees of freedom. So we can see that each degrees of freedom is larger than chi2 test statistics. Like 21 is larger than 12, and 523 is larger than 472. So we can get the result that product CD is dependent with card 4, card 5, and card 6. Next. And the next procedure is data pre-processing. This is our route. We do the first part is dealing with missing values and outlier binning normalization, and the last one is feature construction. Next. We do the we dealing with the missing values and dropping some of the features first. This in the table, it can be seen that we base on a principle that it's a percentage of missing values in each features. If the percentage of missing values is larger or equal to 60%, we'll drop the features. And if it's less than 15, we'll impute mean in numerical features. And if it's larger than 15 and less than 60, we will impute median. And in categorical features, we will impute the frequent value if less than 60%. Okay, next. And this is the outlier. We have tried to find outliers, and since our topic is to detect fraud, so we believe it's important to keep the outliers, but we can still see that in the plot, we have found some outliers in our data set. Next. The next part is binning. After we have tried to do binning, and we can see that, sorry, I forgot this one. Next, I'll try to explain next. I'll try to explain this evening. And we also do the normalization part. We have tried Z-score and the min-max method, and it all helped to decrease the range, but also for the reason that it's a credit card fraud, so we didn't do the normalization. We just tried to find the method if we can do. Next. And the final part is feature construction. We try to construct categorical features. We wanted to transfer it to numerical features, and we try to apart it from low cardinary to high cardinary. And for low cardinary, we do the encoding method. For high cardinary, we do the one-hot method. Next. So after our data processing, we successfully make the features from 432 to 288. Next.
Oh yeah, sorry, I'm here. You can go to the next slide. Like was previously stated, actually, no, sorry. 5 models were implemented, like GBM, Decision Tree, XGBoost, Random Forest, and CatBoost. 5 metrics were used to assess the models and to find the most suitable model: accuracy, AUC, recall, precision, with a focus on the F1 score, since our data set is imbalanced. Like was previously stated, the models we trained didn't need the numerical features to be binned or normalized, but we kept the rest of the data pre-processing. And since we have over 1 million data points, when the training and test data sets are combined, we decided to split the training data set 30% of that to be the test. So here's the light GBM results. Here, with also the XGBoost and the CatBoost is able to handle unbalanced data sets, but a parameter called is unbalanced needs to be set to true. when we tried this, the results only improved a fraction from the ones you see here. So we decided not to do it with this one or the other two. These results that you see came from from training for 4,200 rounds with early stopping. Next slide. We also showed the validation, evaluation, and error evaluation. In the top graph, the real validation values are the blue dots. You can kind of see them at the top a little bit. And the red dots are the predicted values, or the predicted validation values. Then the green dots in the bottom graph are the error. As you can see, there's a higher density of prediction values at 0 and 1, which are the true values. And there's the highest density of the error points are close to 0. Next slide. A grid search was used, grid search with cross-validation was used to find the optimum set of parameters based on the F1 score. Threefold cross-validation of each set of parameters was used to find the best parameters, which was using Gini. Well, I don't need to say that, do I? Anyway, the metrics that you see here are an average of the 10 folds of stratified cross-validation using the best parameters found, and the standard deviation of these metrics were all less than 0.01. The confusion matrix shown is the result of only one of these folds. Next slide, yeah. Here's XGBoost. I was going to say about this one. Yeah, I haven't written any notes on this one yet. I'll write notes, so you can go to the next slide. So yeah, and you can go to the graphs. I did actually write notes for this one. It was similarly to yeah, there. Sorry. Yeah, as you can see, I didn't really make a lot of notes. I haven't prepped this one too much. So similarly to the light GBM, there's a higher density of the validation prediction values at 0 and 1, and the highest density of errors is close to 0. Most non-negative are positive, meaning that there are most of the errors were false positives than false negatives, which is important for fraud detection. Next slide. A grid search with cross-validation was also used for random forest. The optimum set of parameters was based on the ROC-AUC score. A 4-fold cross-validation for each set of parameters was used to find the best set of parameters. More folds were not used due to time restrictions. So yeah, the confusion matrix here is the result of training with the best set of parameters. Next slide. Yeah, so the metrics shown here are an average of 5 folds of stratified cross-validation. The largest standard deviation of the results are the average. Yeah, I said that. Yeah, the standard deviation of the metric results are less than 0.01. And the confusion matrix shown here is the average of the true positives, false positives, true negatives, and false negatives of the 5 folds. Yeah, next slide.
Okay, I'm going to talk about the analysis and assessment of the results. And the first part is business considerations. And for false positive, in our process to deploy multiple machine learning models, the false positive is one of the most. I'm sorry. Isaac? Hello?
What's up?
Did you say anything?
No, I muted myself.
Oh, okay.
Yeah.
Oh, I go on. Okay. The false positive is one of the most important rules for us. And in the business fraud detection field, the companies value the false positive since it will influence the experience of good customers. So for example, when a good customer is tested as positive falsely, the company may lose its transaction and this loyal customer. So when all the other values of the test are the same, we'll pick the models with lower false positive values. And next is auto decision is not omnipotent. So when we make the decision that whether a transaction will go through smoothly, there are usually three scenarios. And the first one is the machine learning model tests and makes the transaction go through without any further requirements. And the second one is the model rejects the transaction with our standards like the low score or any rules that make the transaction fail. The most common scenario is step-up authentication, that the transaction is being held and the text message reply or the ID information is required for authentication. In this way, the machine learning models are faster, more efficient, and more accurate than the traditional methods as we talked before, but it is still not omnipotent. And the second part is a comparison of models. As Alison talked, we have 5 different models like GBM, decision tree, and so on. And we have many standards like false positive, accuracy, rate, AUC, and the record, which is sensitivity, precision, and F1 score. We can see for false positive, the light GBM has the lowest value, and for accuracy, it has the highest value, which is what we need. And for AUC, although CatBoost has a higher value than light GBM, and as we know, as long as the AUC value is bigger than 0.5, it's good. So it's okay here. And for recall, precision, and F1 score, the light GBM has the best performance. So we'll pick light GBM as our model to deploy. So this is the last part. We use a light GBM model to deploy or test database. And we can see with the submission fail, this is the transaction ID, and this is the results of the transaction, whether it is fraud or not. And we can see we have more than 500,000 values here, and this is our final result. And next part.
Hello. Next slide. We learned a lot in this class. Before learning this class, most of our group members are just familiar with C, C++, Java, and other programming languages. Anyway, most of us are not familiar with Python. This class gives us an opportunity to learn Python. We learned a lot of libraries of Python. These libraries are easy to process and visualize data. We learned how to use Jupyter Notebook. This tool is a web application that we can use to create and share documents that contain code, equation, visualizations. It's very convenient to use in machine learning projects. Next slide. We learned the workflow of machine learning. We learned how to deal with data, how to clean the data, how to process data with different models. In the end, we compared which model is more suitable for our project. Next slide. In the process of learning models, we assigned each person one model, and multiple models are performed simultaneously. In this way, everyone can learn how to process data with a model. Then we summarize the results and upload them to GitHub. This model is more efficient. This method is more efficient to get the result, and everyone can learn something in the process. Next slide. This is the part of references of our project. Next slide. Okay, our presentation is done. Any question about our project?
Any question?
No. Okay, so it's all set, right? We can just prepare more and present this evening.
Let me see. Locked out. I don't know why.
What did you say? They're a little muffled.
I see. Can you see page 13? Do you see the range on the right side? The range is negative 81,300. Why is this value?
Oh,
It's transaction amount, so it can't be negative, right? And it's really big. It's a little weird.
yeah,
because
I'll
the median is 0
I'll
point.
rerun this one, get a statistics.
Yes, and the range, and I think the mid-range is correct because the max is 5,000, right? About 5,000, and
Yeah,
cases. Yeah. Gender relation values. Mode. Little worry. And we have any other to discuss about the
I
presentation?
I
Yeah,
just
so
sent few pictures in the Discord group. I just wanted to ask if did we follow that or no?
Yes, accuracy, yes, we have 98%. And false positive rate.
I
Yes,
don't need
think so.
yeah, I don't need the result. Just because we submitted it in the first assignment, maybe professor will check this
Yeah.
PPT to compare. So that's why I'm asking.
Sure. Yeah, I think we have all achieved the standards we made at the beginning. Because let me share. So you can see here, this is the false positive rate. It's only 2.9%, much lower than 5%. And the accuracy is 98.62%. It's much higher than 80%. So we all achieved the goals.
Okay.
Yeah.
Yeah, I just wanted to ask because maybe he would check that presentation if he didn't get something.
Yeah,
Even that would be a
sure.
problem.
I can talk about this criteria and at this point and to show that we have done that. Oh, no more questions. So we are all done.
yeah, I think so.
Cool. Then I think we can finish the report by
I think there's still some time for that.
Sunday. Okay.
Yeah.
Okay. And so you are all good with the presentation slides, right? And I will upload it for the presentation tonight.
Yeah, I
Sure.
think so, yeah.
No more questions? Okay, cool. Okay,
Yeah.
guys. That's it. The semester ends.
I hope so. Hope everything is smooth.
Finally.
Yeah.
Yeah. Actually, I have a question about the data split.
Yeah.
For my part,
Let me find that.
that's after.
I think the beginning of modeling, right? Here.
Yeah, so I figured out, so how for the decision tree, I did it slightly different. I actually combined everything and then split it 30%.
Mhm.
I wasn't gonna mention that directly, since I know the way the model was split for the rest of the models, it was, you split the training data set, right?
Yeah.
Into 30/70, okay, and so is my reasoning correct in thinking like, oh, because we have so many data points, it's okay that we just split the training into 30% test, rest, training?
I think it's okay.
Yeah, okay, because I mean, okay, no, I was just asking if that was an okay reason to say that's why we didn't use all of the data points.
Oh,
We have so
okay.
many.
And I said, if you open the 7 slides the professor gave us, which is A7, and you can find a page which name is holdout, I think. And there is a graph to show how to split it, maybe 70 to 30, and that's very clear. If you like, you can add that graph to this slide. If you like, it's up to you. Just
from
a
the-
suggestion.
The
Yeah.
lecture, the holdout.
Alison, do you mean you're not so sure about the 30% data points? Do you mean the validation part? You are not so sure about that, or sorry, I
Yeah.
maybe didn't listen carefully.
Yeah, I'm just, okay, I'll put in the form of a question. I mean, why did we decide to split the training set and ignore the test data set? Was there a reason that we decided to do it that way?
Oh, cause we split training data set, the 70% for training and the 30% for validation to avoid overfitting, to avoid pollute the model, and we use our model after training to test our original to test our test data set for outputting our results.
Okay, I guess.
If that makes sense, or
Can you just explain that one more time? I'm sorry.
sorry, it's my fault. It's like after we pre-process training data set and a test data set, and we wanted to training the train data set, right? We wanna, but we also wanted to validate if our model after training is good.
I see. I
Yes.
see. Okay, so it's
Yeah,
not
that's the
okay.
reason we split.
Picture. I see.
Okay, so okay, so you used it for validation, not test. Okay.
Yeah.
Okay, and I guess the
This
way I
is
can
train test,
Okay.
and we use 70% of train to train and 30 to do the validation, and we use this result to do the prediction.
I see. So did you use the test data set?
Yeah,
The
we
test is for the final results.
Okay. Sorry. Okay, so I can use this to say that since decision tree is more simple, I didn't use validation. I just used train and test. Does that make sense?
sorry, can you repeat?
Yeah, because for your guys' model, it's a little bit more complicated, so you guys use the validation. But for decision tree, I didn't do the validation at all. I just did train and test. It's like decision tree is pretty straightforward. It's just there's not a lot of training. It's just like creating the tree.
Oh, I think it's cool. I think it's fine. No worries
Yeah.
about that. You
Yeah,
can
I
mention
think
that.
you can just mention that simply like how you do it and don't need to worry about the difference, I think.
Yeah,
I mean,
Because the professor won't go through each code to see. see that
but Alison,
careful.
I have a little question about that. So how do you get the accuracy things of after that? You just get the accuracy things by the training data, right? Because you didn't split it. But I remember you have to do the validation things. I remember you do the across the validation thing. Sorry, I forgot how to put it. Like I remember you do more validation things than us.
Yeah, because
what did I do?
if you see here, this is 70%, and this is the 30% of the training data, right? And we use the testing data to get the results. So 70, 30, and test data.
Right.
Okay.
So this is
So feel
this
free
30 is for validation.
present
Yeah.
yeah. No worries.
Yeah, I don't, I guess, yeah, I don't know exactly what I did. But I don't think he's gonna nitpick. If there's anything we've learned is that he doesn't nitpick. Well, too much, anyway. Yeah, I'm pretty sure. Yeah, I built the tree from the training data set, and then I guess I did the cross
Oh,
validation from the training data set. I didn't do like a separate validation data set.
oh, Alison, I have saw your code. So you concact, train, and test, and
Yeah.
you also do the validation, but you just do the all things. You do the train and test. You split train and test for 70 to 30.
Yeah, that's why I
Yeah,
have like
I see you split code. Yeah, it's fine. I think it's fine. No worries.
yeah. I'm not gonna like draw attention to it, but yeah, I don't think it's that big of a deal.
Yeah, but I think if you do that, maybe training part can't include the test data set because I have searched that and they all said training part can't get the test data set because if you wanna output the test data set result, it will pollute the model. The model will get the answer in advance. So maybe it will influence the accuracy. So maybe next time you do that, it's a point you need to take care. But I think this time it's fine. No worries about that.
Okay, yeah.
Yeah, no worries.
Yeah, so the cross validation that I did to like get the final results, it was kind of like cross validation on the whole data set, and it was like they split up each like from the whole data set. It was they take from the cross validation 30% from the whole data set, and then like it was cross validation on the whole data set.
Yeah, I think it's also good. No worries. Yeah.
Okay. Yeah, I was just following some code that I had a group from another project, which is why I did it the way I did. Yeah.
No worries. But yeah, I just wanna mention you that maybe test can't join the training part because they are afraid of the pollution things. Yeah.
Yeah, I don't think, but test only joined it when I was like doing the cross validation to get the average values.
Yeah, if you do this, it's just like you don't use test to output. You just wanna training the model and maybe So the test is not test, it's training in your homework, in your assignment, as I understand. Because you don't output or get output the submission. You just wanted to try to get the decision trees model result. So that's fine. But if you want to output the test data set, it might get a higher accuracy than we expect if you want to output the test. But if you're just training, it's okay.
Yeah, I just created the decision tree. I didn't do the test with it. Like
Yeah, yeah.
I only did the test with the cross validation later. After the tree was, or did I? I don't remember. Whatever.
Yeah, no worries. It's okay in our assignment. Just yeah, just a notice.
I see what you're saying. I think I see what you're saying.
Yeah, no
Okay.
worries. You have done a really good job. Thank you, Alison.
Thank you. I know you guys have all done a really good job also. You guys are really-
Yeah, thank you guys. I think Hojor is offline. So let's end our meeting. Thank you guys. Let's see each other in the evening.
Yeah, we can end the meeting.
Okay.
Yeah.
Thank you, guys.
Okay.
Thank
See
you.
you. See you. Bye bye.
See you
Bye.
tonight.
Yeah, see you.